Hello class, welcome to day 3 of calculus. We're going to do more limits. So here are my notes. So our informal definition of a limit is that as x gets closer to a, the y value, or the function f of x, is getting closer and closer to a value L. That is a limit. So we're going to look at some of the properties, and the idea is it's really quite easy. It's like we're going to split the limits. So the big thing is that they have to have the same a value to do both the limit of f and the limit of g. You can't have two different limits. Excuse me. Very easy. If you're doing the limit of f plus g, you just add the limits of f plus the limit of g. See addition, you add them together. You see subtraction, you subtract the limits together. You see multiplication, you multiply the two limits together. It's not really that difficult. If there's a constant in front of the function, it just comes in front and you multiply the value. Division, divide, raise to an exponent or a power, you raise the whole thing to a power, or if you take a root, you take a root. It is really that simple. It is just taking whatever limit you have for that function at that x value, and you add them, subtract, multiply. You just do simple operations. Okay, we're going to do some examples here. They're not really that hard. I'll go through a couple and then I'll pause the video. You have to be given the limit of f as x approaches whatever value, and the limit of g as x approaches that same value. So for my example, I have the limit as x approaches 4 of f of x is negative 1, and the limit as x approaches 4 of g of x is equal to 4. So for this first example, well, I'm just going to split them. The limit as x goes to 4 of f of x plus the limit as x goes to 4 of g of x, and well, the limit of f of x is negative 1 plus the limit of g is 4, and that adds up to 3. So my result is 3. It is that easy. Okay, I'm going to pause the video and try some more examples, and you could check your results. You should try these on your own. Check your results when the video picks back up. Okay, as you see, I did examples B through F, and part B was subtracting the two limits. I got negative 5. Part C was 3 times the limit of F, which is negative 3. Part D was 5 halves times the limit of G, which was 10. And then for E and F, I didn't even write out the whole limit notation business. I said, okay, I see the point. So E was just the limit of F times G, which is negative 4. And F was the limit of G divided by F, which also turned out to be negative 4. Okay, I went through examples G through N. G is very easy. Just take the limit of F, which is negative 1, and square it. H is pretty easy. Take the limit of G, which is 4, and take the square root of it. I is a little bit different, so I did write it out. It's really the limit. First part was really the limit of G, and then just adding the 2 at the end. So the limit of G was 4 plus 2 is now 6. J was probably the most difficult one because we have this extra x here. So I rewrote it. It's the limit as x approaches 4 of x times the limit as x approaches 4 of f of x. Well, just for this part alone, if it's x, my rule is plug in x. Well, x is equal to 4, so I got 4. And the limit of f was given, which was negative 1. That's how I could result in negative 4. And k through L, Mn are all, you got to do some multiplication and adding or subtracting, dividing, and all that stuff. And you know, it's pretty simple arithmetic to figure out these limits. Okay, now we're going to talk about something special called the conjugate. So if you have, and the conjugate is changing the sign between two terms in the binomial. So a plus b its conjugate would be a minus b, and vice versa. If you have a minus b, its conjugate would be a plus b. Something happens when you multiply conjugates. Let's look if we go back to what you did when you're in Algebra 1 and you had a plus b times a minus b, and you do the first, outer, inner, last, this double distribution. Well, we get something that looks like a squared minus ab plus ab minus b squared. And we notice these cancel out. And what's left over? A squared minus b squared. You know, that this is a very special pattern that you should recognize. As an example, x plus 3 times x minus 3 just gives you x squared minus 9. You don't get any middle terms. So it's very special when you multiply conjugates. It's like, oh, I really only get these two guys are multiplying each other, and these two guys are multiplying each other, because those two other terms are going to cancel out. So for this example, if I have the square root of x plus 2, then minus 1, its conjugate is the square root of x plus 2 plus 1. And now I'm going to multiply these conjugates. So I'm going to do parentheses x plus 2 minus 1, parentheses square root of x plus 2 plus 1. I don't really have to do the whole, all four terms multiplying each other. I just really need to do these first two terms and these last terms. Well, the square root of something times the square root of the same something is just that something. And then a negative times a positive is a negative 1, and that's how I get these guys. This guy is here, and then it's this guy here. And when I clean it up, it just becomes x plus 1. It's a weird little trick that you multiply by something. So the idea is that we're going to do this on limits, because we're going to see these limits that have these weird square root symbols, and I don't really like them. So I'm going to use the conjugate. So my first rule with limits is plug in the number. So I'm going to plug in 2. I get 2 minus 2 over the square root of 2 minus 1 minus 1, and I get 0 over 0. Unfortunate. It's not what I want. I'm sad. So what we're going to do, we're going to multiply by the conjugate. So if I go back and rewrite this problem, this is x minus 2 over the square root of x minus 1 minus 1, and I'm going to multiply by this conjugate. I'm going to put parentheses around things. I'm going to use a lighter color for parentheses. And then I'm going to get this conjugate fraction, because really, when you multiply the conjugate, you are changing the value of something. But if I do this, and the conjugate for this is going to be the square root of x minus 1 plus 1 now, that's the conjugate. If I do it on top, and we saw this on the previous day, that sometimes we manipulate things by multiplying through by this fraction. This fraction here really equals 1. I'll put parentheses around this. And I'm going to clean it up. On the top part, since those aren't conjugates, I'm just going to leave it as the messy parentheses. As you'll see what will happen. Now, when I do the bottom, Oh, this is the conjugate business. This is where I get, oh, square root of x minus 1 times the square root of x minus 1 is just x minus 1. And then I have minus 1 times plus 1, which is minus 1. And now my whole denominator is really x minus 2. And now I notice I have x minus 2 on the top and bottom, and they cancel out completely. So what's left over? The square root of x minus 1 plus 1. But now I'm plugging in the limit. So let's go back to the beginning of the problem. Oh yeah. Use x equals 2. I get square root of 2 minus 1 plus 1 is equal to 1 plus 1 is equal to 2. So this whole limit is equal to 2. That's what's going on. I wouldn't want to graph this one. It'd be hard to do. I'll do one more example, talking about the whole thing. So again, the first thing I do is plug in my number. My number is 1. And I plug in 1, I get square root of 1 plus 15 minus 4 over 1 minus 1. 1 plus 15 is 16, square root is 4. Oh, I get 0 over 0. You know, bad news. That could be a hint, but they're probably always going to be 0 over 0. So I'm going to rewrite the problem. And now I have x plus 15 minus 4 over x minus 1. I'm going to multiply through, put parentheses, by this conjugate. This conjugate fraction that is really 1, because anything over itself, except for 0 over 0, is just 1. Put parentheses around it. So when I clean this up, the top part has the conjugate, so the square root of x plus 15 times itself is just x plus 15. And then minus 4 times plus 4 is minus 16 over this whole x minus 1 and x square root of x plus 15 plus 4 business. But then I notice this whole thing is really just x minus 1, and they cancel. Don't forget, there's a 1 left over. When something cancels on top, it's not blank. There's got to be a 1 left over. So you're left over with a 1 over the square root of x plus 15 plus 4. And now we will use x equals 1. I get 1 over 1 plus 15 square root of plus 4. Well, this is 16, so I get 1 over 4 plus 4, or I get 1/8. Okay? It's a lot of algebra work, but you better get used to some algebra work. Now I'm going to pause the video, and you can check your solutions to the next 2 examples. Okay, I went through these last 2 examples, C and D. Please, these are something, it's a lot of algebra, but if you keep it all straight, it's not so bad. If you need help with this is what Zoom is for. This is why I want class to be synchronous, so we're all working together, and I can bring it up on the board, and we can try this and that. But, it's just a little bit of algebra manipulation and this and that. It's not above what you can do. It's maybe just a little bit different. Please ask any questions. So now I'm going to switch gears a little bit, and we're going to do some different limits that have trig involved. This is a very special limit. So we're going to do the limit as x approaches 0 of sine of x over x. So my first thing is direct substitution. Plug in 0. I get sine of 0 over 0. And can anybody recall what sine of 0 is? Well, sine is a y value, and when I'm at an angle of 0, that is the point 1, 0, so that is 0 over 0. Oh, darn it. There I go again. This very sad thing. That's no good. I can't do this. So I'm going to put this in my calculator. I'm going to put sine y equals sine of x over x in my calculator. I'm going to try graphing it. So here I have my handy dandy TI-84 calculator. I'm going to put y equals sine of x over x. In here I'm going to use the graph. So I'm going to hit the y equals on the top left. On the bottom of the screen you should be able to see what keys I'm hitting. Then I'm going to type in, I like having that fraction key, so I'm going to hit the alpha, y equals, and I can hit 1 or just hit enter, and I get that nice fraction bar. Sine of x, I'm going to close parentheses, but you don't have to, over x, hit enter, and the way I'm going to graph this, I'm going to go to mode, this mode key right here. I want to make sure I'm in radian mode, not degrees. You get to calculus, everything's radians. And then I'm going to hit the zoom key. And I'm going to pick the 7th one down that says Z trig or zoom trig, so number 7. And this is the graph you get. And we're looking as x gets closer to 0. So let me minimize this for a second. So my question is, as x gets closer to 0, where is the y value getting closer to? Well, let's look back. Where's my pointer? Here we go. Oh, as you get towards the y-axis, it looks like we're getting closer and closer to y equals 1. If you look very closely here, look, everywhere else is nice and smooth. There's really a hole there at the graph. Holes do not matter for limits. Remember, our limit is, what is the intended y value? As x gets closer to 0, the y value is getting closer and closer to 1. So we've just seen that y gets closer to 1. So we saw the limit as x goes to 0, sine of x over x is just 1. Let's try this in the table. So I'm going to look at the table. I'm going to come over here. It's already in my calculator. I'm going to set my table. So I'm going to go to second window, which is a table setup. And I'm going to start the table at 0. I'm going to make my delta table, the increments, 0.001, enter. And then I want to see the table. And when I want to see the table, I hit second graph, and I see the table. And I use my arrows to go up and down to see everything that's going on. If you notice, if you bring it over here, it's not exactly 1. So when I'm at negative 0.003 and 002 and 001, it shows 1 on the calculator, but they're really not. If you look at the bottom of the screen here, you can see it's a little bit different. But every time I get closer to x equals 0, I'm getting closer to y equals 1, even though here it says error, because it gives you 0 over 0. It should be an error, but not for limits. So that's pretty neat that we've seen on our table that the limit here is 1. So how about if we do sine of 2x over 2x, or sine of 3x over 3x, or sine of a half x over half x? Well, let's go to our calculator. We'll go to, I don't know, let's go to the graph. Let's change it in our y equals and change this to 3x, and on the bottom, 3x. If you have this special key, it's great because then I don't need parentheses around the whole denominator. And now when I do the graph, oh, the graph changed its look, but the limit is still 1. If I go to the table, the limit is still 1. X equals 0 is getting closer and closer to 1. So that didn't change. If I try 2x, graph is a little bit different. It's not as wavy as the 3x one, but it still has a limit of 1, and so on and so forth. So it looks like what we have, let me move this up, Let me get out of here. These are all ones. I could do the point half x, it would be 1. So the idea is that sine of kx over kx is 1 for any value, for any non-zero value for k, as long as these are the same k's. Sine of 100x over 100x is going to be 1. Let's try a little bit different. What if it's sine of 2x over x? How does that change? Let's go to the calculator and go to y equals and do sine of 2x over x. Oh, got stretched out a little bit. Now, looks like the limit is 2. How about sine of 3x over x? Hit the wrong thing. So sine of 3x over x. Oh, now the limit is 3. So I think I'm seeing a pattern here of sine of 2x over x is 2, sine of 3x over x is 3, sine of 0.5x over x is 0.5. So it looks like sine of kx over x is equal to k. And now I'm going to show you why. Because if I do sine of 2x over x, and I multiply it by the fraction 1. Well, let's see. Many ways to write 1. How about 2 over 2, and now I have 2 sine of 2x over 2x, and we saw that this sine of kx over kx, as long as they're the same, this part is equal to 1, so I have 2 times 1. And then conversely, the other way around, I could split this fraction to make this 1/2 times sine of x over x, and this part is equal to 1, so it's a half times 1, this is a half. This is a third. This is 1 over 0.5, which is equal to 2. So my conjecture is sine of x over kx is really 1 over k, and better yet, when I have sine of mx over kx, well, I have an m here on top and a k here on the bottom. So it's all based on the limit of 0, limit as x approaches 0 of sine of x over x is equal to 1. Next page, we're going to try some examples. Okay, the next page of this example, some of these are pretty basic. Well, sine of 5x over the sine of 5x is just 1. Sine of x over x is 1, so with the 3 in front is just 3. Sine of x over 4x, well, sine of x over x is the 1, so this is 1/4. This makes this 2.3. This is 5/3. And this one I think I have to split up. The limit as x goes to 0 of 2x over x plus the limit as x goes to 0 of sine of x over x, and I have, well, these x's cancel, so I have 2 plus, we talked about this for the last 5 or 10 minutes, sine of x over x, that limit is 1, so this whole limit is 3. Okay, these last two examples are like the ones I gave you the other day, but I think we have to get used to practicing more of this complex fraction. Obviously, if I plug in 0, you're going to know by now you get 0 over 0. So this is the whole thing of multiplying through by something to get rid of things that make it easier. Again, we're multiplying through by a fraction equal to 1, so this one I just use these denominators here and do 6, x plus 6 on the top and bottom, and then I'm going to distribute here and here, and I get 6 minus x plus 6 over 6x x plus 6 equals, well, this is really 6 minus x plus, oops, my bad, minus 6 over 6x x plus 6. And that gives me, well, these 6's cancel out. Negative x, 6x, x plus 6. And now these x's cancel out. I have negative 1 over 6x plus 6. Remember, we're using x equals 0. I plug 0 in here, and I get negative 1 over 36. Negative 1 over 36. Same thing here. I'm going to use these denominators and do 2, x minus 2, 2, x minus 2. And now I'm going to distribute here and here. And I get 2 plus x minus 2 over 2x, x minus 2. And the numerator just becomes, these 2's cancel. I get x over 2x, x minus 2. And these x's cancel, leaves a 1 left over. Equals 1 over 2, x minus 2. And I'm using x equals 0. I get negative 1/4. So this whole thing is equal to negative 1/4. Okay, that does it for this video. Please come to Zoom, ask questions. We can go through it. I know that you've had a summer off and even longer when you talk about the last 2 months of school. It's just a lot of algebra work, but you guys are good in math, so you should be able to do this all. Okay, thank you.